Good day, AP Biology students. Welcome to Video Lecture Episode 9. Today we're continuing Chapter 31, which we barely started yesterday when we finished up on Slide 19 talking about important plant hormones. And remember, Chapter 31 is titled Plant Responses to Internal and External Signals. Now, looking at Slide 20, we're going to see just some visual images of one of those plant hormones, and that's the effects of gibberellin on stem elongation and fruit growth. In slide 20, you'll notice on the left-hand side there's a picture showing about the stem elongation effect that has, and then we're seeing on the right-hand side the effect of fruit growth, and that dealing with grapes. Slide 21 shows us another one of those important plant hormones, and that being ethylene gas and how it deals with fruit ripening. And notice that the image on the top right-hand side shows where there's this canister in there, and that canister actually has ethylene gas, which releases so that the bananas will actually ripen so they're ready when they get to the store. Then on the left bottom corner, we have the example just comparing the same fruit, but one that's untreated and one that's treated with ethylene treatment, and that being tomatoes, and you see the difference it makes there as well. Now, slide 22, we're going to start talking about plant movement. We're going to talk about tropisms, and we're also going to talk about Turgor movements. Now, let's start with tropisms first. That is growth responses, and if you notice it, the growth response is too slow. Okay, so phototropism is light. That's one of those. Oxym. There's gravitropism, which is gravity dealing with oxygen as well, and then thigmotropism, which is touch. So we have light, gravity, and touch affecting the movement of plants and them actually slowing down and being affected based on this. Number 2, we have Turgor movement. Allow plants to make relatively rapid and reverse responses. For example, think about the Venus flytrap or the mimosa leaves that sleep. The mimosa leaves that have what we call sleep movement, where those leaves close in. Okay, you've probably seen both a Venus flytrap and a mimosa leaves. If you haven't, you can look up there's some YouTube videos on it that you can check out. Now let's go to slide 23. Positive graphotropism in roots, the stalolith hypothesis. So the stalolith hypothesis, just like I said, it's an educated guess on what happens. And the slide 23, once again, like it mentions positive gravitropism in roots, the stalolith hypothesis, and shows the difference, okay? Or at least, basically what seems to be suggested by the data. Now let's go into 24 and look at thigmotropism, and where there is rapid Turgor movements by, for example, here, the mimosa plant action potential. So if you look at the image in the middle, if you look on the left-hand side, it says the unstimulated state, and notice the leaves are open. And then if you look on the right, the stimulated states, the leaves are closing up into like a sleep. All right, that's pretty cool, I think, personally. All right, and let's go ahead and let's finish off our discussion today on slide 25 with plant responses to light. Plants can detect direction, intensity, and wavelength of light. Phytochromes, this is just a term I'd like us to define in connection with this concept and this the principle we're going over here, and that is light receptors absorb mostly red light, regulate seed germination, and shade avoidance. So that's what phytochromes are. Right? I do hope this lecture has been helpful. If you have any questions, you can leave them in the comments below. Reach out to me via Google Messaging, send me an email, or even meet with me during my office hours from 1 p.m. to 3 p.m. Have a nice day. Hope this has been helpful. Thank you.